So now we get into the second piece of our discussion, okay? And that piece is, why do I bother to pair up the x's and the y's, okay? And it's because there are two concepts we need to talk about next. One is domain and the other is range. So let's dig into that, okay? We said before that f of x is really just a fancy way of saying y. What is the output of the function when I input an x? Well, that answer is the y that I get when I calculate the function with x in it, okay? All right, so f is the name of the function. That's why we just say f for function, f acting on x, or f of x, and y is the output, x is the input, okay? So the deal is, if I collect all of the x's, all the values that you could possibly put into my discrete function, okay, that is called the domain, okay? Apologize for the car alarm. Okay, we're doing this live. Okay, and then if I want to collect all the y's, if I say give me all the y's of my discrete function, okay, that's called the range, okay? And for the rest of the slides, to give you a little hint, here's my f of x. X is the input that's inside the parentheses of the function, and the output is y, which is on the other side of the equal sign, okay? And the domain, because it's all the x's, are all the horizontal x's. So all the x's is the domain. Notice that the domain is on the horizontal axis. And the range is all the y's, so it's on the vertical axis, okay? So that's my little hint to you for all these remaining slides. The range is all the y's, the domain is all the x's. The x's are the inputs, and the y's are the outputs of the function, okay? Here we go, okay? Once again, we start with a discrete graph, okay? We already figured out what are all the x's, the inputs, and when I put in all the inputs, what y's do I get? Well, here's the list right here, right? We said f of x is equal to y, the input x's and the output y's, right? So if you say the domain is the set of all the x's, well, how do I list the domain? How do I list all the x's? Well, they're right here. There's a 1, 3, a 5, a 7, and a 9. So when I ask you to collect all the x's and call it the domain, well, the domain is just a 1, 3, 5, 7, 9, all the x's, right? In the same scenario, right? Well, what are all the y's? What is the range? Well, all the purple numbers, all the outputs, right? For the answer, the y for 1 is 2. For 3, it's 4, 6, 5, 3. 2, 4, 6, 5, 3. Notice that when I'm just listing the answers, I don't necessarily write them in number order, okay? This one is in number order, but this one is not. If I were to write them in number order, I would write the range as 2, 3, 4, 5, and 6, okay? All right. So that's the domain and range for a discrete graph when we're talking about just dots. Hopefully, you're finding that's a very easy concept to understand, okay? Let's apply it now, that same simple concept of domain and range, to a discrete table, okay? So let's say these are all my x's and y's from the last time. And again, we figured all of those out. So all the inputs are in green, all the outputs are in purple. Well, all the inputs are all the x's, and the domain is set of all x's. So I'm going to pause now to give you a chance to list the domain, list all the x's. Okay, we're back. And just listing all the x's, you can just read it from the table. -6, -4, -2, 0, 2, 4, 6. Same thing here. -6, -4, -2, 0, 2, 4, 6. And listing them all out like this, that's all my x's, and all my x's together are called domain. Okay? Now, all the range, all the y's, are just the outputs in purple. So it's 4, 6, 8, 10, 12, 14, 16. They're in fact written right on the table. 4, 6, 8, 10, 12, 14, 16. And that's all the y's. And that's my range, is all the y's. 4, 6, 8, 10, 12, 14, 16. Okay? So that's the case when I give you the discrete function in the form of a table. Now, the last thing we talked about is how do you figure that out when it's a mapping? Okay, so hopefully you figured that out. It's pretty easy. I just got to figure out what are all the x's and then what are all the y's. Okay, but there's a little bit of a trick in this one. See if you can spot it. Okay, here's all the x's, here's all the y's. We figured it all out the last time, right? Here's my domain, all of the x's, inputs, right? 10, 5, 0, 3, 6, 9, right? 10, 5, 0, 3, 6, 9, 10, 5, 0, 3, 6, 9, okay? Now, I'm going to pause here to let you figure out what is the range. Okay, gave you a little extra time, so hopefully you didn't fall for the trick, okay? Take a look at this y. Is this y going with any x? No. Okay, so even though it's listed, it's not part of my range, right? Let's take a look. If the outputs are all 10, 20, 0, 10 again, remember I can have two 10s here as long as none of the x's are going to two, not one x is going to two different y's, right? So I can have repeats here. Okay, so 20, or rather 10 is used twice. And then I have 0, 18, and 12 right here. So there are six in my domain because the x's are 1, 2, 3, 4, 5, 6 different numbers. Okay, and the 10 I only list once, even though it's listed twice in here. I only list it once in my range. Okay, and I have 5 because poor little 6 over here was not used in the range. It didn't match with any x's, so it's not part of our range. Okay, be careful about that. Okay, now we get the sense of the ordered pairs. It's arranged a little differently, but the concept of domain and range in this discrete set is still pretty much the same. Give me all the x's, list them all, and give me all the y's, list them all. So all the x's we call domain, all the y's we call range. So I'm going to give you a little extra time to figure this out. Go. Okay, let's take a look at all the input x's, the domain, right? Well, it's pretty simple. -2, -1, 0, 1, 2, 3, 4. -2, -1, 0, 1, 2, 3, 4. There it is, okay? All right. And now for the range, it's just all the y's, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There it is. Okay, so that's how you handle domain and range when the function, the discrete function, is given to you as a set of ordered pairs. Okay, so you might say, wait a second, Mr. Tablizo, I thought we're not talking about continuous graphs. Why are you talking about a continuous graph here? It's true. This is a continuous graph with an infinite number of points. But when it comes to domain and range, sometimes they just are interested in a set of very specific points, a set of discrete points. In this case, they're saying, hey, give me the range for when I limit the domain of this infinite number of x's to just -2, 0, and 2. So sometimes that's a problem. You're going to see where that is how they phrase discrete domain and range. Okay, so let's take a look. Okay, it's still f of x is equal to y, so I put in the x in the parent. So if they're interested in a negative 2, I say, where is negative 2 on the x-axis? Negative 1, negative 2. What is the y that goes with that x? Well, with 1, 2. So f of negative 2 is a 2. Well, what about 0? Well, here's x equals 0. What's the y? Also 0. So f of 0 is 0. Okay? What about f of 2? Well, 1, 2. There you go. F of 2 is also 2. Okay? So now we say, just for these three very specific or discrete points, if you give me this domain, I'm going to give you the range. And what I got was 2, 0, 2. And in fact, I wrote it duplicating the 2. Your answer should also be just 2 and 0, right? I repeated this, and that's still okay, but just to be strict about it, you should just put 2 and 0. Okay? All right. So sometimes this range, for when you limit the domain to just a few discrete points, that's called the solution set. So the way they're going to ask you the question on a test is, what is the solution set for this continuous function when the domain is -2, 0, 2? And you figure out the outputs, and there's your solution set. Okay, so that's our discussion for discrete graphs on how to use function notation on them and how to do domain and range for discrete functions.